Hello, teachers. We're still in Chapter 12. This section is Section 12-3, and it's actually a really small section. In this section, we're going to talk a lot about constructions. We've already learned several constructions. I do want to remind you that there are videos available in your Canvas course for all of these constructions. So if you're having trouble looking at the diagram that I'm about to show you in this presentation, please consider watching the videos, especially when you have to do the constructions on your own. So after this section, you're supposed to be able to discuss constructing parallel lines. We have two different ways to construct parallel lines: angle bisectors and perpendicular lines. Okay, and we're also going to talk about angle bisector properties. Now, the first construction that we're talking about is one of the two ways to construct parallel lines, and this is actually called the rhombus method, because what you do is you build a rhombus. You don't go as far as building a rhombus, but if you had to construct a rhombus, this is the way to go with it. Okay, now first thing, the first square they show with these diagrams, having trouble staying on the lines, is always what you're given. So notice you have a straight line L that you could construct on your own with a straight edge and a point P. So as long as you have a position, point P, and a straight line, you can get started and draw a line parallel to this line L. Okay, so the first thing that you need to do, so I moved on to the second block here, so this is what I'm discussing now, is we need to draw a line through any point A and P. Okay, now I wouldn't make it vertical, okay, because you want to construct a rhombus. I mean, you could, but this is just not the way to go, all right, because you need an angle. If you made it vertical, you wouldn't have an angle going on right there. So you need an angle. So notice it says through P, draw any line that intersects L in A. The line segment PA will be a side of the rhombus. Okay? Now notice what we do next. We make an arc. Okay, so we have moved on to the second step. So with your pointer at A, see your pointer's right there at A, and your pencil at P, you swipe an arc with your compass. Okay, now keep that same distance, okay, with the same opening. Whenever it says with the same opening, keep that same opening, and you make two more arcs. And this is the part that you really have to remember. So you put your pointer on P and strike an arc, and then you go back and put your pointer on X and strike an arc. Now keep in mind, you got that same opening when you do that. So the opening is the arc from A to P, okay? And just like when you measure an angle and you try to reproduce an angle, you do that same thing, all right? But this time, you pick up your pointer and you put it on P and make an arc, then you put it on X and make an arc. Now what does that do? That gives you the next line segment for your rhombus. So see the blue line here that they drew? That's through the intersection of those two arcs, and that gives you your parallel line. So you don't complete the entire rhombus, but what if you needed another line for your rhombus, right? The third line, that's this dash line that they have going on right here. But the blue line that I just highlighted is all you're trying to do. That line is parallel to line L. But if you had to complete a rhombus, that dashed line, I've drawn over it so much it's hard to see, that dashed line coming down from the intersection of your two arcs back to your arc, your original arc, would give you a rhombus as well. So really there's two skills in one here for constructing parallel lines. You could build a rhombus and you could construct parallel lines. Now here's the second way to construct parallel lines. It's called the corresponding angle method, and the reason they call it that is if you look at the final outcome here, these are corresponding angles when you have the two parallel lines you know, and then this line here that we draw on our own is the transversal, and so we have corresponding angles. But let's get started. Notice the first box shows exactly what we're starting with. Notice this is identical to what we started with the last time. We have a line L. We could draw that on our own if we needed to, and a point P. But if you're given a line L and a point P, this is enough. So the first step is the same as the first step in the rhombus method. You need to draw a line from your point P through line L. It's a full line. It continues on in both directions. Okay? Now, what's the next step? It makes it look like it's one simple thing over here because these are methods that we've already learned, but let's talk about in detail what's going on here. Okay? The first thing they're doing here is they're striking an arc, okay, from your intersection at A. So you put your pointer right there at A, and then your pencil right here at P, and strike an arc. So that's this arc right here. Do me a favor and do that same arc. Don't move your compass measure at all, and put your pointer right here at P. Okay, now your pointer's at P, and you strike that same arc right here. All right, now this is happening in step 3, but I'm trying to explain it right here on step 2. Now the next thing that you do is you measure this arc. You've done this before, and that's why they just talk about this in terms of one box of directions. How do you measure this arc? Okay, you put your pointer right here at point P, and you change the distance of your compass to measure that arc, and that's what this is right here. Okay, they measured that arc. And then you pick up your compass and you put your pointer at that other arc right here, okay, and then swipe again. And where that new swipe right here intersects your arc, then you draw your horizontal, your parallel line. Notice the line I drew does not look parallel because I just made up these positions. But that's the way that works. So again, draw the blue line through point P anywhere on L. You don't have to have a specific spot, okay? Then you measure with your compass pointer where they intersect and make an arc through P. I have my eraser on, so make an arc through P. Go ahead and put your pointer now on P and make a second arc that same distance away. Okay, don't change your measure. Now come back and put your pointer of your compass right here on P, and then make an arc here that measures that angle, and you pick it up again and put your pointer here at that second spot, make another arc that's going to intersect, and then you draw your parallel line. Okay, I like this method. I like the rhombus method. They both work great, and I could see that they would both come in handy depending on your situation. All right, the next construction is for an angle bisector. Now, what is an angle bisector? Doesn't mean a lot unless we can speak the language, right? So an angle bisector is a ray that divides this angle in half, okay? So my goal is to divide this angle in half where this angle and this angle are the same measure. Okay, so that's my goal, really. Now, let's go back to what we have to start with. We have an angle. Okay, so you're given an angle. So this is all the information you have. And you have a compass and a straight edge. And that's it. No protractor to measure anything like that. So notice the very first step is you put your pointer at the vertex. And you just strike an arc. And what you're really doing is measuring this angle when you strike the arc, okay? Well, you haven't measured it yet, but you're going to. So you have to strike an arc to be able to measure the angle. So if I read it, it says, with the pointer at A, draw an arc intersecting the angle at B and C, giving 3 vertices of the desired rhombus. So what we're creating a rhombus again, and we actually do that for many constructions, okay? You don't have to think about it that way to get the job done. Now, B and C didn't already exist. Okay, that created B and C. They were not, you see, they weren't already there on your angle. So the arc can be of any size. If you make it too small, it's too difficult to get your compass to work right, and don't make it too big either. All right, so what do you do next? Now, when we look at the third step, we need to be careful about what we're actually measuring here. So I am on the third step. So let's highlight it. Okay, now if you look at the picture, it's not clear what you open the compass to. It looks like the pointer's at B, clearly, and they strike an arc. And then we come over here and put the pointer at C, and we strike an arc. But how wide does the compass need to be? That is the measurement AB. So you come back here and you measure a radius AB. So you put your pointer on A, okay, and your pointer on B. Now, turns out that hasn't moved. So when it said to just strike an arc initially, you don't change your compass size at all. And then you pick up your pointer, you put it on B, and then you strike an arc. And then you pick up your pointer, don't change a thing, and put it on C and strike an arc. And where they cross is actually your angle bisector. So that happens here. Okay. Now, notice the rhombus that we just built as well. So where they strike will be your parallel side. If you connect your point B to the intersection of the two arcs, that gives you the side that's parallel to AC. And then notice over here, if you connect your intersection D back to C, that's parallel to AB. So again, if you needed to build a rhombus and you already had an angle, no problem. You really do the same steps as you would do for an angle bisector. And again, remind me, what is an angle bisector? An angle bisector divides this angle in half. Okay, we have another construction. I told you this section was lots of constructions. Remember, there are videos available for this as well. But I really like the diagrams that they've selected, because if you're good at reading these diagrams, it's right there for you. You don't have to keep watching the videos over and over again. But watching them one good time, I think, is a good idea. So where are we starting? Well, what information do we have? We are trying to construct perpendicular lines, and we're given a line and a particular point. So your perpendicular line might not have to be at any place in particular, but if it does have to be at a particular point, we've got it. Now, what's a perpendicular line? My goal is to draw a line through P that goes through L and meets it at a 90-degree angle. So that's the ultimate goal, is I'm trying to do that, again, without a protractor, just with a compass and a straight edge. All right, how am I going to do that? So the very first step, you'll notice, is put your pointer on P, and then just strike an arc. How wide does it need to be? Well, where you intersect the line twice. So certainly you don't want your arc above the line. You don't want it just touching the line. You would like a clear space between A and B. But where it strikes the line, you call that point A and you call that point B. So easy enough, right? Just strike an arc. Now leave your compass with the same opening. Okay, just leave it open, and then put your pointer on A and strike an arc, and then put your pointer on B and strike an arc. Okay, you see that? So again, the arc that you built originally, you leave your compass that way, you pick up your pointer, you put it on A, and you strike an arc that's somewhere over here, and then you put your pointer on B, and you strike an arc that's somewhere over here. Okay, and you'll see you can connect up point P with your two arc intersection, which they call Q, and that's going to give you your perpendicular line. Okay, now notice it built a rhombus. Here we go again with the rhombus situation. So let's highlight it. Okay, so it doesn't, your rhombus is not the perpendicular line, but if you connect P to your arc strike A and P to your arc strike B, and then connect A to your intersection and B to your intersection, you also have a rhombus. All right, so perpendicular lines from a particular point. Very easy to do as long as you remember the directions or you have them in front of you. Okay, this is one of my favorite constructions. I think you're really going to like this one. What we're doing is we're bisecting a line segment. Okay, so what does that mean? All right, bisecting means to divide it in half. So we don't have a point that we're trying to do like we did on the last one. We're trying to draw a perpendicular line. We are, again, bisecting. But you know what? It is going to still be a perpendicular line when we do, and it's called a perpendicular bisector. So perpendicular bisector. Okay, how do we do it? Easy enough. You take your compass, okay, and you put it on the point on A, and you make sure you open it over halfway. Okay, now if your line segment is super long, that could be a problem with your compass, okay? Hopefully your line is not insanely long compared to your compass. You've got to open it over halfway. And when you open it over halfway, notice you strike an arc. Okay? Now, do not change the opening in the compass, and you take that point over to B and you strike another arc. Okay? Notice the intersection here and here. You connect points C and D, and that gives you your perpendicular bisector. So what's really going on? When you finish this line, then I can say the length from A to M is where your perpendicular bisector intersects, is the same as the length from B to M. Also, this line that we drew meets at a 90-degree angle, so it's perpendicular and it cuts your line segment in half. Also, I feel incomplete because I didn't shade all this in. We talked about it all, right? But I didn't shade it all in. Now, did you notice something at the end here? We built another rhombus. Like for all of these, not every one of them, but for almost all of these, we've built a rhombus. Now, you don't have to. We just wanted the perpendicular bisector. But if you connect up your intersection points, C and D, to your endpoints, there's our rhombus right there. Please tell me you remember what the definition of a rhombus is, right? So it's a parallelogram, which means this side is parallel to this side, or opposing sides are parallel, and this side's a parallel to this side. And not only that, all four sides are congruent. They're the same length. Now, this problem is called example, but really it's just another construction, but it's not a new construction. This is why they called it an example. So given triangle ABC, there it is up there, okay, this is what we're starting with, construct an altitude from vertex A. Now, you need to know the definition of altitude to pull that off. An altitude of a triangle, and you've heard this before, this isn't the first time, from a vertex comes down perpendicular. So that's my goal, is to draw an accurate, why'd that disappear? Altitude. Okay, so that's my ultimate goal. Now I'm going to get rid of that. Now we've already learned how to draw a perpendicular segment. Okay, so I'm not trying to draw a perpendicular bisector. Okay, I can't do that. Well, we're not doing that. That's not the altitude. That's something different. Okay, but I'm just trying to draw perpendicular from a point. So that's the first perpendicular situation we learned. So remember, what you do is you put your compass point right here. So there's your pointer. And you strike an arc. It doesn't have to intersect over here at B. Notice this one doesn't. Just strike an arc that intersects the line down here below, the line BC. Now keep your compass open the same distance. Okay, don't change anything. Then you put your pointer here and strike that arc. Don't change a thing. Put your pointer here, strike that arc, and connect up A and the intersection D. And what you found is your altitude. So the segment from A to line BC over there, or segment BC, is the altitude of your triangle. Okay, example 9b, another construction. It says construct an altitude from vertex A. So remember, an altitude, by definition, comes from a point and then goes to a line and makes a 90-degree angle. So from point A, here we are, up here. I'm trying to, there it is. Okay, now I'm supposed to come down and draw a 90-degree angle. And you're like, wait a minute. Inside this triangle, there's no way in the world that's going to be a 90-degree angle. turns out I'm going to come outside the triangle, and I'm going to have to extend this line over to get my 90-degree angle, or perpendicular is what that is, right? So it's okay. What do? You just extend BC. Okay, so notice they came out and extended BC. And let me remind you how to do a perpendicular line. Okay, so this is not the same as a perpendicular bisector. We're not trying to split up a line segment into two equal parts, because this line really goes on forever down here. That's not what's happening. Now, what do? The steps are, you put your pointer right here on A, and you strike an arc. How long does it have to be? It just has to intersect the line in two places, okay? Don't make it too short and you just barely touch. Don't make it too wide where it's too difficult to deal with. So just strike an arc. Do not change your compass setting. You put your corner or your pointer right here, not your corner, your pointer right here with the same compass measurement, and strike that arc, and then you pick up your pointer and put it right here and strike that arc, and once again connect your vertex A to your intersection point down here, and that's going to give you the altitude, which is your perpendicular line. Right there is your altitude. How about example 9C? What do you think about this? It says, given triangle ABC, construct an altitude from vertex A. Are you thinking about that too hard? So here's A. Remember, on the first altitude, let's go take a look at 9A, problem 9A. It went from A, and then inside the triangle, we got a 90-degree angle. Like, okay. And then 9B, we had to go outside the triangle because every possible line inside the triangle would not give us 90 degrees. Okay, we had to come outside. Well, this thing, you're thinking, isn't that already 90 degrees? It sure is. Look, your altitude is right there. It happens to be line segment AB, and that's all there is to it. So triangle ABC is a right triangle. The altitude from vertex A is the side AB. So again, your altitude is right here. No construction required. Aren't those your favorite? Okay, there's something to be said about these three examples. Let's go back and look at 9A. What kind of triangle do we have going on here where your altitude is inside the triangle? This is an acute triangle, isn't it? Okay, so that's at least an acute angle, and your altitude is inside the triangle, but this is an acute triangle. Now let's look at our next example. Notice this one, the altitude was outside the triangle. And what kind of triangle are we looking at? So if I'm going back and looking at my original triangle right here, and you would go, oh, that's an obtuse triangle, right? This angle is over 90 degrees, so that's an obtuse triangle. Well, maybe when you find an altitude of an obtuse triangle, it's going to come outside of the triangle. Now, not necessarily for every altitude. Could you not find the altitude coming from B? That altitude could fit inside the triangle for sure. But what about the altitude from C? Okay, so you're trying to come down in here. That's not going to work. It's going to be out here somewhere. You see what I mean? To get that 90 degrees. So when you are finding the altitude of an obtuse triangle, some of those altitudes are going to land outside of the triangle. And then when you have a right triangle, the altitude is just going to be the side of the right triangle that has the 90-degree angle. The altitude coming from C would also be that side. Now, the altitude coming from B would be different, right? It would fit inside the triangle. And finally, we're going to wrap up this conversation with properties of angle bisectors. What does that really mean? We talked about an angle bisector divides this angle into two equal angles. Just like a bisector of a line segment divides the line segment into two equal parts. Well, any point P on an angle bisector is equidistant from the sides of the angle. So if I just pick a random point right here, it is the same distance from P to the line segment AX, okay, at point D, and it from P to the line AY at point E. These are the exact same distance. If I were to pick another point, say right here, and this is a different point P, again, we can measure the distance by going perpendicular to that line, which is the line AX, and then perpendicular to the line AY. And again, these line segments are going to be the same length, okay? Which really means they're congruent. Now, the second statement is just that statement in reverse. Any point that is equidistant from the sides of an angle is on the angle bisector. So if you know you have a point that is the same distance from side AX and side AY, it must land on the angle bisector. So say there's some point out here that we already know is the same distance from here as it is over here, then it must land on the angle bisector. And that wraps up the video. So again, lots of construction here. Me talking through it is probably not the best way to learn it. Maybe you're not even watching this video and you're just watching the construction videos to get the job done. If you have any questions at all, please let me know and come back for section 12.4 where we get to wrap up chapter 12.